Okay, good morning. Today we are going to discuss vectors 2. So we shall be revising the topic using these questions. Now, we are going to start with here, where we have our first question. But before that, the topic entails an introduction to vectors, then three-dimension vectors, then position and column vectors, then magnitude of a vector, or what we call the length, the modulus, and the distance. Then we have collinearity, collinear vectors. Then we have ratio theorem and line division. Then finally we have application in geometry. Okay, so this is what we are going to discuss in the topic. Now we are not going to tackle each and every subtopic, but we shall do this in form of revision questions. So here we have a question that is trying to tell us to get the value for these vectors, then work out on the collinearity. Okay, so we have a vector here. We have position vector O, move to C, moves to A. So O is the center of origin, and there's a distance traveled from O to C, and another one traveled from O to A. So the questionnaire is telling us OA is vector A, and here we have OB, and OB is vector B. So from O to A is positive vector A. Now, if someone moves from A back to the origin, we call that negative vector A, because you are returning back to the origin. So displacement from the origin O to another point A is positive A. The same movement on the same path from A to the origin is negative. So here we have OC is equals to 3OB. So already OB is B. Now BO becomes 2B, and the whole of this line is 3B. Okay? Then we are told now to express AB and AC in terms of A and B. So the first vector we have is AB. So this means that you are standing at point A and you want to move to B. So the options that you have is you come back to O, then move to B. That's one option. So AO plus OB, that is one option. Another option is you move to C, then back to B. Or you move to AC, then to CB. Both paths will take you to point B. That the displacement is from A to B. So we are moving from A all the way to B. Therefore, you can take this path AO or AC. Whichever way you take, we are going to reach at B, and the solution will be the same. So AO, we have OA, which is positive A. Now AO returning back becomes negative. So negative A plus OB is positive. So that's one way. Okay? So, and you are done. So we have solved this or expressed this in terms of A and B. Okay? So we can as well have the same AC and CB. So AC is AO plus OC. So AC is AO plus OC. And then CB is now going back. So it is negative 2 over 3 of no, CB going backward, so 2 over 3 of OC, 2 over 3 of OC. Okay, so AO is negative A plus OC is 3OB, so it's 3B plus minus 2 over 3 times OC, which is 3B. So by 3, 1 by 3, 1. So we have negative A plus 3B minus 2B. So plus 3 minus 2 is 1. So we have negative A plus B, the same value that we had here. So whichever way you go, the answer becomes the same. But if you look, this path is more longer than the other one. So that's one. The next point we are going to express is AC. AC. Okay, so we are at point A, we want to go to C. The simplest way to go is through the origin, AO, OC. So we have AO there and OC. So AO is the reverse of OA, which means negative A, plus OC, which means 3OB, which is 3B. And that's done. So we have expressed AB and AC in terms of A and B. Good. Now next question is, given that AM, now we are at B, AM is 3/4 AB. It's 3/4 AB. So here first we have N. Let's put N here. Then we join that. So we have M. So AM is 3/4 AB. So this means this is A to M is 3, M to B is 1. So this means that A to M, M to B is 3:1. Okay. And we are told AN is a half AC. So this means AN to NC is 1:1. So the ratio becomes a half. Now from there we are told express OM and ON in terms of A and B. So we have our OM here, vector OM, from the point O to M. Now you want to travel from O up to M. You can pass at 2 points. One, you can move from O to B, then to M, and you have this triangle. So you can have OB plus BM. Another path that you can take is, you can move from O to A and A to M. So you can as well move from O to A and A to M. So OA plus AM. Okay, so let's start with the first one. OB. Position vector OB is B. So we have vector B here plus BM. Now BM lies on the line AB. On the line AB. So the displacement starts from A to B. If we come back from B to A, we are going to have a reverse displacement, which is negative. Therefore, BM is 1/4, 1, which is BM, over 4, which is the whole line. BM to MA is 4. BA. So BA is the reverse of vector AB. Okay, note that. So now we simplify this. B plus 1/4. Now BA is the opposite of AB. So we go and look for somewhere we solved AB. We have AB here. So if AB is negative A plus B, BA becomes A minus B. A minus B. Why? Because we are reversing. We had negative, we started with A. Now B becomes negative because the first displacement is B. So we simplify this. We have B plus 1/4 A minus 1/4 B. Okay, collect the like terms together. So we have B minus 1/4 B plus A. So B minus 1/4 B means 3/4 because this is 1. So we have 3/4 B plus A. So that is OM using this method. So we can as well use the other one, okay, so that both of them will give us the same answer. All right, the next thing that we are expressing is ON, vector ON. So you're at O, you want to go to N. So you can move through C and you can move through A. So OC, CN, OA, AN. So let's take OA plus AN. OA is vector A plus AN, this is 1, 1. N divides the line AC into 2 equal parts, where AN is to NC is 1:1. So AN becomes a half AC. So A plus a half, we have calculated AC somewhere. We have expressed, AC somewhere here. So we put negative A plus 3B. This one will give us A plus minus a half A plus a half times 3 is 3/2B. So here we have A minus a half A plus 3/2B plus, sorry, here we have a quarter A and here we have a quarter A. This simplification contains a quarter A. Yes. Okay. So 1 minus a half is a half A plus 3/2B. So this is OM, this is ON. We have expressed OM and ON in terms of A and B. Now before we proceed, look, the answer for the first question A is obtained from the diagram by looking at the displacement in the diagram, okay? The answer for B is obtained from A. That's why here we had BA. And in A we calculated AB. So the reverse of AB will help us in the workout of question B. The same case for ON. When we were solving ON, we had AC. And AC has been expressed in question A. Okay, so we move on to here to the last part. Now show that O, M, and N are collinear. Okay, so what were the conditions for collinearity? Number 1, the vectors should be parallel. And what do we mean by parallel? One should be a scalar multiple of the other. Okay. Then number 2, there should be a common point within the line. So we should have a common point within the line, fine. Number 3, all the points should be on the same straight line. Okay, are our points parallel? We will prove that. Do we have a common point? Yes, we have a common point because this is OM and this is MN. So we have OM to MN. That is the line. Okay, so MM is a common point in both of them. Okay, are all the points on the same straight line? Yes, we have line OMN. So the line is straight. So what is missing is the proof for parallel. So we're going to prove if these points are parallel. And we say the parallel one should be a scalar multiple of the other. So we get OM is equals to 3/4 B plus a quarter A. We have ON is equals to a half A plus 3 over 2B. Now, you compare the coefficient of the vectors. Okay? So we compare the coefficient of the vector. We start with A. We have a quarter A in OM is equals to a half A in ON. So the relationship between a quarter and a half is a half. So this means that if I multiply a half by a half, I will get a quarter. And if I multiply a quarter by 2, I will get a half. So therefore, I can say here, if I multiply here by a half, I will get this one. And if I multiply here by 2, I will get this one. So it means there is a relationship between the two coefficients of 2 and a half, depending on which side you are multiplying from. Good. Now the same case, let's check for B now. That is for vector A. Vector B here we have 3/4 B is equals to 3 over 2 B. 3 over 2 B. So if I multiply a half here, I will get 3 over 4. And if I multiply here by 2, I will get this one, 3 over 2, and this is the reverse. So, what does that one mean? That if you have OM, which is 3/4 B plus a quarter A, and ON, which is a half A plus 3 over 2B, if I multiply this by 2, I will get OM. And if I multiply this by a half, I will get ON. I will get ON. So OM is equals to a half ON, and ON is equals to 2 OM. So we have a coefficient here, 2.5. So therefore, OM is a scalar multiple of ON, while ON is a scalar multiple of ON. Therefore, OM is parallel to ON. Hence, the points O, M, N are collinear points. Why? Because they have satisfied the three conditions. One was for them to be parallel, and being parallel we mean that one should be a scalar multiple of the other. We have proven that through calculation that OM and ON are parallel because one is a scalar multiple of the other, and the scalar that we are going to use here is a half and 2. So if you multiply 1 by 2, the other one is obtained. So OM is parallel to ON, and therefore the 3 points are collinear. Okay, that was how to express vectors, position vectors. Then how to find out whether two pegged vectors are collinear or not. So the principles for collinearity is one, that they should be parallel, they should have a common point, and they should all lie on the same line. So this is the second question that we are going to discuss. All right. The solution. So we are told in the figure alongside OS is 3/4 OB, OP. So OS is 3/4 OP. So S is on the line OP. PR to RQ is 2:1. Okay. So let's have the diagram here. So Q, P, O. So we have S here, and we have R here. So OS is 3/4 of OP. So S is here. So this means 3:1. PR to RQ is 2:1. So OQ is Q, OP is P. Okay. The line OR and SQ meet at T. So question A, given that OP is P and OQ is Q, express in terms of P and Q, vector PQ. So we are at point P, we want to travel all the way to Q. So we return back to the origin O, rest for a while, and then continue with the journey up to Q. So O to P is positive P. Returning back to the origin, we have said is negative. So therefore, we have negative P plus Q, which is positive. So this can be rearranged as Q minus P. Okay. So the second question we have is OR, an expression for OR. So you are at O, you want to travel to R. So you can move through P or through Q. Okay? So let's move through P. OP plus PR will give you the same answer if you move OQ plus QR. But remember, QR is reverse of PQ. So therefore, that vector will be negative. Okay, OP is vector P plus PR. So line R lies on the line, point R lies on the line PQ. So therefore, PR is 2/3 PQ. And we have worked out PQ in Roman 1. So therefore, P plus 2/3, substitute the value of PQ here. It is minus P plus Q. So opening the bracket, we have P plus minus 2/3 P plus 2/3 Q. So this one is P minus 2/3 P plus 2/3 Q. So P minus 2/3 P, we have 1/3 P plus 2/3 Q. So that is OR. We are going to use these expressions later. So let me write them in black so that we see them. OR, and this is OP. Okay. The third one is SQ. You are at S. You want to move to Q. You come to SO, then to OQ. Or you go to SP, then to PQ. Whichever way you go, the answer has to be the same. OQ or SP plus PQ. The route at the origin is always the shortest. So you take that one. Okay, so SO. Now point S lies on the line OP. So coming back to the origin is negative because we are moving from S to O. So we have negative 3/4 P because OS is 3/4 P. So SO becomes reverse. Then this is plus Q. So this one also needs to be in bold because we are going to use it in question B. So we have solved the first part of the expression to express PQ, OR, and SQ. Now we are told, given that, question B, ST is MSQ and OT is NOR. Okay, before we even move to determining the value of M and N, remember we have expressed SQ somewhere and we have expressed OR somewhere. Okay, so this means, as I told you earlier, the answers for the first question are in the diagram. The answers for the second question are obtained from the first question. So it all depends with how keen and accurate you are when working out the first question. Okay, now we want to express OT in two ways. So this is OT. You want to express in two ways. The first way have been given. So OT1 has been given is NOR. So N, we have worked out OR somewhere. So OR is here. So bring it here. A third P plus 2/3 Q. So open the bracket. A third Pn plus 2/3 Qn. That is the first equation. Note that somewhere. OT1. What is remaining is OT2 for us to determine the value of M and N. Now, OT2 must pass at ST. So we have a triangle OST here. OST here. So from the triangle OST, OT2 is equals to OS plus ST. Now, we are at O, we want to go to T. I can pass OQ to QT, but I have been given a condition that I must pass at ST. So when I'm traveling to T, I must pass at ST. So therefore, the only route that can pass ST is OST, which forms a triangle here. So we solve there. So OS is 3/4 P plus ST. Now ST is equals to MSQ. SQ have been expressed somewhere. So that is SQ. So here we have 3/4 P plus M. Okay, let me not take too much space because I will need the entire space here. So OT2 is from the triangle OST. So that OT2 is equals to OS plus ST. OS is 3/4 P plus ST is MSQ. So, and we have calculated SQ somewhere. SQ is there. So 3/4 P plus M, 3/4 P plus Q. Okay? So 3/4 P plus 3/4 PM plus MQ. So here we have 3/4 P plus 3/4 PM. Okay, so we simplify. 3/4 P is common. So we put that outside. So we have 1 minus M, 3/4 P plus MQ. So this is the second equation that we have for M and N. Now what happens is we compare the two equations. So compare and solve the two equations. Okay, so that's equation 1 and 2. So equation 1 is a third Pn plus 2/3 Qn is equals to 1 minus M 3/4 P plus MQ. So correct items together. Let's start with N. No, with P, sorry. So a third Pn is equals to 1 minus M 3/4 P. So N, vector P goes with vector P. We have a third N is equals to 1 minus M 3/4. So let's remove the fraction. 3 and 4. So the LCM is 12. So multiply here by 12 and here by 12. So 4M is equals to 9, 1 minus M. So by 4, 1 by 4, 3. 3 times 3 is 9. So 9, 1 minus M. 3, 1, 3, 4. 4 times N is 4N. So open this bracket. 4N is equals to 9 minus 9M. Collect items together. 9M on that side. So I have 9M plus 4n is equals to 9. Equation number 3. Okay, I have already simplified P. So let me go to Q now. So we have this space. That arrow is not necessary now. So we have Q, 2/3 Qn is equals to MQ. So Q, no. Q. So 2/3 N is equals to M. So remove the denominator by 3 because this is obviously over 1. So the LCM becomes 3. So 2n is equals to 3m. Take this the other side to form a complete equation. 3m minus 2n is equals to 0. Equation 4. Now solve equation 3 and equation 4. Okay, equation 3 was 9m plus 4n is equals to 9. 3m minus 2n equal to 0. These are simultaneous equations. So you can use substitution, you can use elimination, you can use matrix method to get the value of m and n. So let's use elimination method. So we are solving here by elimination. So elimination method. You can use substitution and matrix, whichever method that suits you best, but the answer has to be the same. So we want to eliminate m. So we multiply the coefficient of m of the two equations. So here we have 3 and 9. So we put here 3, we put here 9. So 9 times 3 we have 27m plus 12 of n is equal to 27. 27m minus 18n is equals to 0. So 27m, 27m, they are same sign. So the law for elimination was, if we have same sign, we subtract. If we have different sign, we add. So if the coefficient have the same sign, we subtract. If the coefficient have different sign, we add. So the coefficient of m, which is 27, both of them are positive. They have the same sign. So therefore, we subtract the two equations. So you put minus there. So this cancels. 12 of n minus 18n, that will give us 30n is equals to 27. Because 27 minus 0 is 27. So over 30, over 30. So n is by 3, 9, by 3, 10. So n is 9 over 10. So if n is 9 over 10, what about m? Let's take equation 4. It was so simple. 2n is equals to 3m. But n is 9 over 10. So 2 multiplied by 9 over 10 is equals to 3m. So 18 over 10 is equals to 3m. So over 3 over 3. So m 18 over 30, which will give us by 3, 6, by 3, 10, which will give us 3 over 5. So that is for the value of m. Okay, so we were told to determine the value of n, which is here, and the value of m here. So the methods that were applied shows that all the values that were used in question B were obtained from A. And the ones of A were obtained from the diagram. Okay? So this is the second way in which the questions of vectors can be framed. One was to get the value for collinear, to determine whether what you have is collinear. And the other one is to solve for the values of m and n, or any other scalar that you are going to be given. Okay? So, and OB is vector B. So this is OA and this is OB. P and T divides the lines OB and AB in the ratio 2:3 and 1:3. So point T divide this line into, in the ratio, it was OB in the ratio 2:3.